In this video, we're going to talk about parallel and perpendicular lines. First, we're going to talk about parallel lines, and then we're going to talk about perpendicular lines, and then we're going to look at some examples and how this falls into algebra. So first, let's talk about parallel lines. Parallel lines are lines that never intersect. They look like this. Algebraically, two lines are parallel if they have the same slope. If we take a look over here real quick, I graphed y equals 3x plus 4 and y equals 3x minus 2. Hopefully you remember that the coefficient of x is the slope, and it's the same here. And you can see when I graph them, they are indeed parallel. They never intersect. They have exactly the same steepness, so they're never going to cross. If I change this to something else, I don't see the crossing here, but if I go all the way down, they do, in fact, cross. So these are not parallel or perpendicular. They're just lines that intersect. Perpendicular lines are lines that intersect at 90-degree angles. They look like this, a perfect cross. Algebraically, two lines are perpendicular if they have opposite reciprocal slopes. So one must be positive and one negative, and then they're reciprocals. No, I messed that up. Reciprocals of themselves. Opposite reciprocal slopes are flipped and switched, and I'm going to show you some examples here. So for example, if you had one slope was 3/4, then the opposite reciprocal slope would be flipped and switched. So it would be 4/3 and negative. These would be perpendicular slopes. If you had negative 3/5, then think about what would be the opposite reciprocal slope. It would be flipped, and the sign would switch to positive. So these would be opposite reciprocal slopes, which would indicate parallel or perpendicular lines. A little bit of a tricky one is when it's a whole number, like 4. What's the flipped of 4? Well, 4 is the same as 4/1, so if I flip it, it's 1/4, and then it would be negative. So if it's a whole number, it's going to be 1 over that whole number is going to be the reciprocal or the refliprocal. What if the slope is 0? What would the opposite reciprocal slope be? Think about if it's a horizontal line of a slope of 0, then it would have to be a vertical line that would be perpendicular to it. So the opposite reciprocal slope would be undefined. Taking a look at it graphically, I can see that these are actually perpendicular slopes or perpendicular lines, and when I come over here and look at their slopes, they are flipped and switched. Do you see? It's flipped and the sign is switched. And so that's an indication. Doesn't matter what the y-intercept is. That's an indication that they are going to be perpendicular lines. Now that we've talked about what parallel and perpendicular are, let's look at some examples. So given ordered pairs, determine if segments AB and CD are parallel, perpendicular, or neither. So segment AB is formed by these 2 points. CD is formed by these 2 points. Are they parallel, perpendicular, or neither? So when you see this question that's asking about parallel, perpendicular, or neither, alarm bells should go off in your brain and say, slope, slope, slope. It has to do with the slope. No? No alarm bells? Well, they should be going off. Slope has to, parallel, perpendicular, or neither has to do with the slope. So start finding the slope. You'll remember that that is y minus y over x minus x. So 6 minus 3, since I started with 6, I have to start with 2, minus a negative 2. So the slope of AB, this is AB's slope, is 3/4. Circle it, label it M. CD's slope is 3 minus 0/3 minus a negative 1. So that's 3/4, circle it, label it M. So CD's slope is 3/4, so they are the same. Does that mean they are parallel, perpendicular, or neither? If you said parallel, you are right. So just to recap, if it's asking you about parallel, perpendicular, or neither, you need to find the slope somehow. If they're the same, it's parallel. If they're opposite reciprocals, flipped and switched, it's perpendicular. And if they're neither one of those things, so if they're not the same, they're not flipped and switched, then that means they're just lines. Just lines that intersect, nothing special to them. Let's look at another example. So sometimes we might give you equations and determine whether it's parallel, perpendicular, or neither. Can I give you a little bit of a hint about notation? This is a fast forward to geometry for a second. Parallel, the symbol for parallel looks like this. The symbol for perpendicular is an upside down T because it looks like they're perpendicular. And neither is just neither. So that's a little bit of shorthand for you. Are these two parallel or are they perpendicular? And again, alarm bells go off. I'm asking a question about parallel or perpendicular. That means I need to look at the slope. Can I tell what the slope is here? I can. It's y equals and y equals, so that means the coefficient of x is the slope. They both have a slope of 7, so that means these are also parallel. How about these two? Are they perpendicular or parallel? I just did that backwards. Parallel or perpendicular. So they're not the same. They're both 1/3, but one's negative, one's positive. So they're not the same. Are they perpendicular? Are they flipped and switched? Well, they're not flipped. They're switched, but not flipped. So it's not perpendicular either. This is a neither. If they're the same, it's parallel. If they're flipped and both switched, it's perpendicular. And if they're not any of those, then it's neither. Just two more examples. Again, for these two equations, are they parallel or perpendicular? And we have to be able to find the slope. So maybe by looking at this, you can determine that these are a little bit different than the ones before. What's different about these than the current problem? Do you see? If you said they're not solved for y, they're not in slope-intercept form, you are correct. These are in standard form. So I got to do some rearranging before I can tell what the slope is. So let me start with x plus 6y equals 3. I'm going to rearrange into slope-intercept form so that I can tell what the slope is. And I do that by solving for y. Box around this, circle everything else. 6y equals negative x plus 3. E moves to the other side and becomes the opposite sign. Divide everything by 6. Y equals. Now, there's no number here, so that I'm going to make that a 1. I'm going to put x next to it. And then I don't really care what that is because I'm only interested in the slope here. So the slope of this one is negative 1/6. Now let's take a look at this one. 3y equals 18x minus 6. Also not in slope-intercept form, but it's real close. All I have to do on this one is divide by 3 because the x and the 6 are already on the same side together. Now, are these parallel or perpendicular? Well, they're not parallel because these aren't the same. But are they perpendicular? Are they flipped and switched? The signs are switched. One's negative, one's positive. And they're flipped. Flipped and switched. So it is perpendicular. Because remember what I said, I could stick this over 1, it's still 6, and then the reciprocal is 1/6, and now they have opposite signs. So yes, they are perpendicular. All right, one more example, it's fast. Y equals 6, x equals negative 1. Whoa, what are these? Well, here's an equation that has no x in it, it's just y. So that's one of those special cases, do you remember? Remember our Hoy and Vux? Y is a horizontal line with a slope of 0. So this is a horizontal line, something like this. And this is an x equals with no y in it. So it's a vertical line. Are those perpendicular? Yes. This is a perpendicular. Definitely not parallel. If they were both y equals 6 and y equals -1, then they'd be parallel. But since it's y equals 6, that's a horizontal line. Doesn't matter where it is. It's going to be a horizontal line, and this is going to be a vertical line, and that makes them perpendicular. You can also remember that this one has a slope of 0, and this one has a slope of undefined. And those are flipped reciprocals of each other. All right, hopefully you have an idea now, at least a basis for how to find parallel and perpendicular lines from ordered pairs and equations.